Okay, welcome back. So right now we're going to look at some of the properties of these pairs of angles that are created when a transversal crosses two parallel lines. It's important to remember that if the transversal does not cut across parallel lines, that it won't have these properties. But if it does, then we can use these properties to solve for angles that are unknown without using a protractor. So let's start with our first one, A. So it's asking us to solve for this angle. And what we have essentially here in the diagram is something like this. We have our transversal, we have a couple of parallel lines, and we are asked to find this angle here, which is x, if we know that this is 95 degrees. Now, if you remember from the last lesson, we found out that this and this are both what's called they're corresponding angles. They're in a corresponding position. And according to our rules when it comes to transversals and parallel lines, any angle, the pair of angle that is corresponding as a transversal cuts across two parallel lines is going to be equal. So in this case, x is equal to 95 degrees, or x degrees is equal to 95, and we can put in reasons corresponding angles. Alright, now if we look at B, it might be a bit different. We have essentially, we've got the same type of thing. We've got our transversal, we've got two rough parallel lines, and we've got x degrees here and 125 degrees here. And these two angles here are vertically opposite, and vertically opposite angles are equal. So we can say in B that x degrees equals 125 degrees, and the reason is vertically opposite angles. Alright, so this is pretty simple, but it's very useful to be able to make these kinds of logical leaps and provide a reason for them. Ultimately, they'll help you with later problems. Alright, here's a couple for you guys to practice, so just give them a go, pause the video, and then I'll solve them in a moment. Alright, let's get started. So for C, what we have is again a transversal, and we have two parallel lines creating lots of pairs of angles. We have x here, and we have 45 degrees here. Now again, if you remember from earlier, these are corresponding angles, and corresponding angles are equal. So we can say x is equal to 45 degrees. And the reason is corresponding angles. Alright, let's look at D. So for D, we have to learn about co-interior angles. Now if you've read the notes for this lesson, that's great. But if you don't know, then we can go over it very quickly. So when we have two angles that are essentially co-interior, and co-interior just means that they are right next to each other, they are going to have to add up to 180 degrees. So for our question here, we have 65 and we have x, then we can write that x plus 65 degrees, or x degrees plus 65 degrees, must be equal to 180 degrees. Now using this logic, we can write x degrees is equal to 180 degrees minus 65 degrees, and that is equal to 115 degrees, and the reason is co-interior angles. Alright, so with every single set of co-interior angles, they're going to add up to 180 degrees if we are dealing with a transversal, which is this line here cutting across these two sets of parallel lines. So this pair here would also have to add up to 180 degrees as well. Now this can also help us a lot with determining some more tricky applications of this knowledge. Alright, that's it for this video. Hope it was helpful, and I will see you in the next one.